Hello, it is Mrs. Scarpel, and in this video I'm going to go over some information regarding function notation, how we can use graphs to complete some function notation problems, and how to evaluate functions. So to start off with, we have this example. Find the value of y when x equals 5. What you want to do is you want to look for where we have 5 on the x-axis. So here's 5 on the x-axis, and then you want to go to the point on the graph that corresponds to that x value, which is down here. And then if we go to the left and we read the value on the y-axis, we know that when x is 5, y will be -2. The second one says find the value of x when y equals 0. Well, y equals 0 is going to be located on the x-axis. So the x-axis is the line y equals 0. So when y equals 0, we're looking for the values of x that correspond to that y value on the graph. And you'll see that we actually have 2 of them. We have one at, it looks like it's halfway between 2 and 3, so we can say x is 2.5. The other one, as we move further along the x-axis, is when x is 7. So it is possible to have more than one value correspond to a given value. So what does this do for us today? So function notation is what I'm going to introduce to you here. Function notation is something that looks like f of x, and it's just a name for y in a linear function. So for example, I have f of x here instead of y equals 3x plus 9. This is still a linear function. I have mx plus b form, but instead of writing y, we're giving it a name. We're giving it f as the name, and x is the domain, or the input. So, and when I read this, I read it as f of x, not f times x or fx. It's not an actual operation. This is a name. And it doesn't always have to be f. I could say g of x, h of x, r of x. I could even change the input variable. Instead of being x, it could be t, m, b, whatever the function is. So when we have something like evaluate f of x equals 2x minus 7 when x equals 4 and x equals -4, this is actually asking us to evaluate it for 2 different values of x. So we're going to come up with 2 different values when we evaluate. So if I start with f of x equals 2x minus 7 when x equals 4, think of it as you're being asked to evaluate y equals 2x minus 7 when x equals 4. Now when you have things in terms of x and y, and you know that x is 4, many of you would tell me, well, you're going to plug 4 in for x and solve for y. That's the exact same thing I'm going to do with my function notation. I'm going to replace the x with 4, even in my notation. So my function f, when x is 4, will equal 2 times 4 subtract 7. And we, just like I would do over here on this equation that has x and y, I would just simplify the 2 times 4 subtract 7. That's all I'm going to do here. I'm going to keep the function notation. Remember, it's not an operation. 2 times 4 is 8. Subtract 7. So the value of our function when x is 4 is 1. So we can write this as when x equals 4, y equals 1. That is also an ordered pair for 1. Now in your assignment that goes with this, you're not going to have to write out these statements that I wrote in blue, but you should get yourself familiar with what this notation is saying. So it's saying when x is 4, y is 1. So let's evaluate the function when x is negative 4. So f of negative 4 will equal 2 times negative 4, subtract 7. And just like we did before, we're going to simplify the right-hand side. So that's negative 8, subtract 7. That means f of negative 4 will equal negative 15. In other words, when x equals negative 4, y equals negative 15, or we have the ordered pair negative 4, negative 15. Now, why would you need to know how to evaluate a function? Well, you might be asked to graph a function. So here we have the function f of x equals 2x plus 5. And we're going to graph this. When you do that, start with an input-output table. So my input is x, and my output is f of x. And we're not given specific values, so I'm going to choose negative 2, 0, and 2, and I'm going to evaluate this function for each of these values of x. So that is 2 times negative 2 plus 5. 2 times negative 2 is negative 4, plus 5 is 1. Now evaluate when x is 0. 2 times 0 plus 5 is going to be 0 plus 5, or just 5. And then evaluate when x is 2. 2 times 2 is positive 4, plus 5 gives us 9. So now we have 3 ordered pairs. We have an input of negative 2 with an output of 1. 0 and 5, 2 and 9. We're going to plot those 3 points on our graph. So when x was negative 2, we got 1. When x was 0, we got 5. When x was 2, we got 9. And then what we can do is graph a line. See if I can pull up my line tool here real quickly. And let's get the color for that. I'm going to put it in red. And I can graph a line that goes through those points. So that line is representing the function. This line represents the function f of x equals 2x plus 5. So that's the graph of the function. Now let's go back to that warm-up that we had. Here it's being listed as an example. Find the value of f of x when x is 5. So just remember, f of x is a name for y. So we're going to be looking for f of 5. So just like we did in the warm-up, when x is 5, find the corresponding y value that goes with that point, and we have f of 5 equals negative 2. Find the value of x when f of x equals 0. So f of x, remember, is a name for y. So when y equals 0, what x value or values are being used. So I find every time I have y is 0 on my graph, and when x is 2, so f of 2 equals 0, and f of 7, or not 2, excuse me, equals 0. This is actually at 2.5, so we need to revise that. F of 2.5 equals 0. And then the other one is f of 7 equals 0. So in the assignment, you're going to actually be practicing finding the values using the graph, but everything's given to you in function notation.